All right, time for a proof. Gonna start by marking up the picture with a given and kind of coming up with a mental plan for how to do this proof. So MN is congruent to AT. Sorry. And then MATH is a parallelogram. Now there's a lot of marks that we can make for a parallelogram, but I'm gonna go ahead and just say, since it's a parallelogram, AT is congruent to MH. And then since we've got these two sides congruent, if I just focus in on the triangle MHN, those two sides being congruent make it an isosceles triangle, which give me those base angles congruent. And that's what I'm trying to prove. So now to write it out. If I do not zoom out, I'm not going to be able to read my writing. There we go. Should make it a little bit better. All right. So I'm going to start with, I'm actually going to start with the MATH as a parallelogram. I think it's going to make my proof a little bit smoother. So MATH is a parallelogram. Man, I wish there was an abbreviation for that. Is a parallelogram given. Let's change up the colors so it's a little bit easier to see. Since it's a parallelogram, we can say that MH is congruent to a T. Reason is property of parallelogram. So opposite sides in a parallelogram are congruent, so that means that MH is congruent to AT. Now I'm going to hit with the other given, that MN is congruent to AT, given. And then I'm going to flow those two together since they're both congruent to AT, then MH is congruent to MN, and that's a little transitive property. We could also use substitution there. Now I've got those sides congruent. Now I'm going to say angle 1 is congruent to angle 2. And my reason here is going to be, I know we want to say something about isosceles triangles, but actually here we've got base